Hello everyone and welcome back. So this time we're doing a very similar problem to last time, but I won't beat around the bush. Now you know that there's actually going to be two values for P that we can solve for. One where motion would impend up the hill and one where motion would impend down the hill. Up and down. Okay, now this time also you can see that P is at a 40-degree angle with the horizontal. It's not perpendicular to the surface, but it's definitely going to be changing things when we were just pressing up the hill. However, our steps are all the same. We just have to decide what direction we're going to move. So I'm going to say we're going to be saying it's going to be impending up the hill first. So we draw our free body diagram. We get our load P, our weight, which is 200 pounds, our normal force right here, and then we're going to have the frictional force, which is going to be resisting that motion, which is going to be equal to our static friction coefficient times the normal force. And I'll say that the static friction coefficient is going to be, make it 0.25. 0.25. Okay. Now that I do all my angles, so that one right there, that's 40 degrees. This one right here, that would also be 40 degrees. Yes, it should be correct. With that in mind, yeah, okay. Sorry, I'm just freaking out a bit like, did I do it correctly? I did. Okay, so with that in mind, we can now solve. Like, we have enough here. This is plenty to solve this problem. We should do some of the forces in the x, which is going to be equal to P cosine of 40 minus my friction force. That's might have confused you, but I was saying that this is my x-axis and this is my y. It can make things a little bit more simple. But I did forget one more force. My 200-pound weight is also going to have a component that's in the x direction. So it would be this component that's opposite of our hypotenuse. So it also have weight sine of 40 degrees. Okay, all that's equal to 0. I know my weight is, so I should go ahead and plug that number in. Then some of the forces in the y direction, and that's going to be equal to, put my normal force pointing up, and I have my weight cosine of 40, which is going to be 200 cosine of 40, pointing down. And I also have part of my component P here, which is going to be pointing down. So 40 degrees is this angle, so that's opposite over hypotenuse. So minus P sine of 40. And you can see this is more or less just the reverse of each other when it comes to the components. And all that's equal to 0. Now if I solve, well, what do I get? Well, I will get that the load P is going to be equal to, I believe, 97.4 pounds. 97.4 pounds. Okay. So now let's look at the next situation. Motion is basically, what am I doing? I'm sorry. I have it written down. That is, P is going to be equal to 276 pounds. Sorry. 97.4 is if we're going down the hill. Yes. Gotta read my own notes correctly. Okay. Now, what else can we figure out here? Well, we know if we're going down the hill, the only difference is that friction is going to help us. Everything else stays exactly the same. So all I have to do is change the direction of friction in this equation. Boom. That's it. That's the only change to all my equations. I went from a minus sign to a plus sign. And if I solve them all, I'll get P is equal to 97.4 pounds. Now, isn't that amazing? Just by setting it up nicely and being very careful, you're done. Like, I didn't have to do any extra work. I didn't have to write down my equations again. I didn't have to do my free body diagram again. All I had to do was switch one arrow's direction, and I was able to solve. So you can make these kind of problems easy if it asks for either bound. Most of the time I'll ask you for one of them, so I guess you're not going to really benefit from that too much. But still, it's there. It can be helpful. Okay. So, with that in mind, that's it for this one. Thanks for listening. I'll see you all next time. Bye-bye.